Hello, everyone. In our last class, we started with the chapter Permutations and Combinations. In that chapter, the first and primary thing that we talked about was when to add our options and when to multiply the individual option. If it is a situation of and, I want each one of the things to occur, then we multiply. And if I want only one, either this or this or this, if it is a situation of any one, then we add. So we add when there is a situation of or, we multiply when there is a situation of and. Now, in normal scenario, what we do is whenever we are asked to do a task, we talk about if it's a word or it's a number question, it's a mathematical question. Then we talked about how the first place can be filled, how the second place can be filled, how the third place can be filled, and we add or multiply. But if it is not a mathematical question, it is a common sense kind of a question. In that things, what we do is we ask ourselves, how will I do the sum? For example, first scenario, the mathematical one. If I tell you that I have the digits 1, 2, 3, 4, 5, 6. I have 6 different digits. I want you all to form a 4-digit number. I want you all to form a 4-digit number. In how many ways can I do that? In how many ways can I form a 4-digit number using the 6 given digits?
Three 60 ways.
360.
Tell me in multiplication.
The first digit can be filled in 6 ways.
Very good.
The
Since there are
second digit,
total 6, the first place can be filled in 6 ways. Any one of the letter can sit. So one of them is already sitting here. What will be the second place option?
5.
5
5.
ways.
The third
4 ways.
and the last.
3
Three
So
ways.
since I need to fill each one of the places to make a 4-digit number, it will be 6 into 5 into 4 into 3. That's
360.
360. Yeah,
Yes, ma'am.
Yes.
everybody? Okay, now what I want is an even number. If I want an even number, what will you do? I want an even number. If I want an even number, in that case, the last place has to be filled by an even number. So the last place has how many options?
3.
3. Either 2 will sit, or 4 will sit, or 6 will sit. So the last place can be filled in 3 ways. Out of a total 6, one of them will sit in the last position, if either 2 or 4 or 6. So I have a remaining 5 letters.
5.
So first place can be filled in
5
5
ways.
5,
ways.
next
4 ways,
4
4,
ways.
and then 3.
3
3.
ways.
5 into 4 into 3 into 3. So in exam, what we'll do is, since I want an even number, the last place has to be filled in either by 2 or 4 or 6. So there are 3 ways. Now, while filling up the first position, we can fill it by using any of the remaining 5 letters. One of them sits there. The second position can be filled by any one of the 4 remaining letters, and the third place can be filled by any one of the remaining 3 options. So a total 5 into 4 into 3 into 3 by 6.
360 ways.
हाँ,
120. 180 ways.
options 3 है ना, बैठेगा कोई एक. I have 3 different ways to fill that. If I want an odd number, if I want an odd number,
135 will sit in this place.
135 can sit in the last place. So there are 3 ways to fill
3
this
ways.
position. Again, the first place can be filled in
5 ways.
5,
5 ways,
then
4
5,
ways,
4 ways.
3 ways.
3
and
ways.
3 ways. Yes. So answer would be 5 into 4 into 3. Any doubts?
No, ma'am.
No, ma'am.
All of you? What is the divisibility rule for 4?
Ma'am, it's it end with
Last
2
two
zeros.
digits divided by 2.
Last 2 digits should be
Divided by 4.
Yes. The last 2 digits should be divisible by 4. Agree? So in this case, if I want a four-digit number which is divisible by 4, then what should I have? The last two places should have a combination of number which is a multiple of 4. So from these 6 options, first I will see how can I use these digits to make the placement of the last two digits so that they become a multiple of 4. Agree? So what can I write?
24.
12, then from no, 16 is also then.
Yes, ma'am.
24,
32.
32, 36. I can't have
36.
44, right? I don't have two fours. 52, 56,
64.
any other? Anything else?
No, ma'am.
No.
No,
So
ma'am.
the last two digits can be filled in 8 ways. Any one of the pair will sit there, yes or no?
Yes, ma'am.
Ma'am.
Yes,
So
ma'am.
out of total 6, 2 of them will sit there, either 1, 2 or 1, 6 or 2, 4, any one of the 8 options. But 2 letters will be occupied. So I have a remaining of 4 letters. So the first place can be filled in.
4 ways.
4
The next
ways.
place can be filled in.
3 ways.
3 ways.
Total 4 into 3 into 8. Clear?
Yes, ma'am.
Yes, ma'am.
Now the problem will come if I give you 0. Okay. Now what is the problem? If I want to suppose a 3-digit number, if I want a 3-digit number, and what will be the total options in your capacity? What do you think? In the first place, I cannot have 0. Why? Because if it is 0, 1, 2, it won't become a 3-digit number. So there is an inbuilt restriction whenever we have an option of 0. So 0 cannot sit in the first place. No other restriction was provided to you. So 0 cannot sit in the first place. So the first place has
4
4
ways.
ways.
one of the person will sit here, one of the number will sit here. So out of 5, one of them is already sitting here. So the next place will have, because the
4
next place
ways.
has no problem with 0. So the next place has
4.
4 ways. The third place will have.
3 ways.
3 ways.
So a
Ways.
total of 4 into 4 into 3. Clear?
48.
48 ways.
Whatever. Clear?
Yes,
Yes.
ma'am.
Then if I tell you an odd number, I want an odd 3-digit number.
Last place can be filled by 2 ways.
1 or 3, 2 ways.
Yes, ma'am.
But there is also an inbuilt restriction that 0 cannot fit in the first place. So I have a total of 4 digits left, but in that 4 there is also a 0. So 0 cannot sit in the first place. So first place has how many options? 3 options. The first place has only 3 options because 0 is not allowed to sit here. Yes.
Yes,
Yes,
ma'am.
ma'am.
So out of 5, first and last place is filled. I'm left with
2 ways.
no.
3 ways.
3 ways.
Only 2 digits were used. I had a total of 5 options. 1, 0, 1, 2, 3, 4. Out of that, I used 1 to fill the first position. I used one of the digit to fill the last position. So only 2 of the digits are used. So the second place can be filled by remaining.
3 ways.
3 ways.
So total 3 into 3 into 2.
3 ways.
Clear?
Yes, ma'am.
If I want an even number, a 3-digit even number,
Last place. Last place can be filled by 2 ways.
what are the 2 ways?
No, ma'am. Last place can be filled by 3 ways. 0 to 4.
Okay.
And
3
there will be
ways.
2 cases.
Yes,
one and
because
three.
0 has a problem with both the first place. 0 cannot sit in the first place, and I want 0 to sit in the last place. So 0 has to be looked up for two different places. So I can't deal with it together. So we form two cases. Case 1, if 0 is sitting here, there is only one way to fill this position. So now I have four digits left. In those four digits, none of the letters digits has a problem in sitting anywhere. So the first place can be filled in,
Four ways.
and the
Four
next
ways.
place can be
Three
filled in.
ways.
Three ways.
3
So 4
ways.
into 3 into 1,
Total
that
of
is 12.
12 ways. Yes,
Now,
ma'am.
if the last place is filled by anyone outside 0, which is
Two and
either
four.
2 or
2 and
4. So there are two ways to fill this position. So only one will sit here. I
Yes,
have a
ma'am.
remaining 4 digits. But in that 4, there is a 0. But 0 cannot sit in the first place. So how many options for the first place?
Three.
3. So out
3
of
ways.
5, one of them sits in the first place, one of them sits in the last place, 2 gone, remaining.
Three ways.
3
So 3
ways.
into 3 into 2,
18
18,
ways.
a total of 30. Now I'll add because it's odd. Either your even number will end with 0 or your even number will end with 2, 4. Is it okay?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All of you okay? Guys okay?
Yes, ma'am.
Yes,
Yes.
ma'am.
Now we come to scenarios where it's a common sense question. Suppose I give you 3 letters and I tell you that you can post them in 5 post boxes or post offices. So in such a scenario which is non-mathematical, what we do is we figure out how will I do the sum. So what we do is we pick up the letter and go to the post office. Same way we will think. So I pick up the first letter. How many options for me to post them? First letter can be posted in how many ways?
5
5
ways.
ways.
5 ways. The second letter can be posted in how many ways?
4
Five ways.
ways.
5 ways.
Again, 5 ways, because one post office does not have only one letter, right? It can be posted in the same one. The third letter can be posted in
5 ways.
Again 5
so
ways.
a total of add or multiply.
Ma'am,
Multiply.
Multiply, because I have to post the first letter and the second letter and the third. I have to post all of them. If it would have been post any one letter, then I would have added. So it's multiplication 5 cube
5
120.
cube 125.
Yes.
Yes, ma'am.
Yes, ma'am.
Now there is a small twist to it. In how many ways can you post 3 letters in 5 post offices so that all the letters are not in the same office? I've added an extra condition. All the letters should not be in the same office. So what I don't want all the 3 to be together. I don't have a problem with 2 together. I don't have a problem with all of them being different. I have a problem with all the 3 together. So if all the 3 are not together, does that mean that all of them are different? No. It can be that or 2 of them are in the first box and one is in the other. 2 of them are in the second box and one is in the other. 2 of them are in the third box, one is in the other. Or all the 3 are in different boxes also. That's possible, right? So there are different cases. Agree? Rather than doing that, what can we do is from the total possibilities, we will remove the possibility that I don't want. So what is the total possibilities of posting these letters? 125. We just calculated. This was my total. From this, I'll remove which is not acceptable to me. What is not acceptable? All 3 letters in same box, right? I have a problem with this case. If I remove this option, yeah, these options, I get my final answer. Yes or no?
Yes, ma'am.
Yes,
So how
Yes.
many ways are there for me? Think, huh? How many ways are there for me to post all the 3 letters in the same box? How many boxes? 5. How many letters? 3. I want all the letters in the same box. How many ways are there to do that? Yes. How many ways are there for the 3 letters to be in the same box? Did I tell you which box? No. They all 3 can be in box 1. All the three can be in post office 2. All the three letters can be posted in post office 3. All of them can be posted in the fourth one. All of them can be posted in the fifth one. So how many options are there for me to post them all together?
5.
5. And those 5 ways are not allowed. Other than that, I'm allowed to do anything. 2 together, 1 different, all different. Everything is allowed. I'm only not allowed when I dump them togetherly in one office. So I can dump them all together in the first office. That is one way. I can dump them all together in the second office. That is second way. I can dump them all together in the third office. That is third way. So there are total 5 ways to do that. Agree? So I have a problem with only those 5 ways. So from the total, I'll remove these 5 cases. So answer will be 120. In these 120 ways, what's going on? All the 3 won't be together. 2 can be together. They can all be different. Anything can happen, but all the 3 won't be together. Yes or no?
Yes,
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 ma'am.
ma'am.
क्यों? मैं वो हटा रही हूँ जो मुझे नहीं चाहिए. मुझे तीनों साथ में नहीं चाहिए. तो 4 क्यों होगा तीसरा? नहीं, मैंने किया all 3 in the same box. I want all the 3 letters in the same box. I'm removing that case. I have a problem with all of them being together. So what is the possibility for them to be together? They can all be in the first one. They can all be in the second one. So there were 5 possibilities. I removed those 5. I have a problem with those 5. So whatever are the ways remaining in that, all the 3 won't be together. So your question, 2 in 1 and 1 I'm okay. That's there. In those 120 ways, that's included. Guys, clear?
Yes,
yes,
ma'am.
Everybody clear?
Yes, ma'am.
Suppose I tell you there are 5 flags of different colors, red, yellow, and all those. There are 5 flags of different colors, and you are sending a signal like a mosque. So red, yellow, white means something. Say help. White, yellow, red will mean pick up. Red, blue, green will mean something else. Right? So every combination will mean something else. So you are going to send a signal using 3 colors, using 3 flags at a time. Right? How many ways are there to do that? Answer. Yeah, there are 5 flags in total. You are sending a signal using 3 flags at a time. How many ways are there? So if I have to fill up 3 position, right? I have to use 3 colors. So the first position can be filled by any one of the 5 colors, any one of the 5 flags. Yes or no? If I used a red color here, I can't use red color again. So the second flag can be chosen in how many ways?
4 ways.
4 ways.
The third flag can be chosen in how many ways?
3 ways.
3 ways.
So 5 into 4 into 3. Yes?
Yes,
नहीं.
Yes.
अगर पहले में रेड बैठा दिया तो सेकंड में वापस रेड कैसे हो सकता है? सिग्नल क्या है? Everybody clear?
Yes, ma'am.
There are 6 lights in the room. Normal lights. Huh? Every light has a normal switch. On, off. No dim, no frequency change, nothing. No common switches. Normal. 6 lights, 6 switches. That case. In how many ways, how many combinations are there for these lights? How many possibilities are there for me to use these 6 lights? I can use all 6 at a time. I can use 5 at a time. I can use 4 at a time. I can use 3 at a time. I can use 2 at a time. I can use only 1 at a time. I may not use at all. Agree? There are different ways. I'm asking you what is the total possibilities. Okay. What is the possibility that there will be light in the room?
6.
How? How 6?
6 by 7.
6 by 7.
Mhm.
It's not
ma'am,
the
720 ways.
how. Whatever you are telling me, how.
Ma'am, suppose if we keep 6 lights in the room, in order to keep the first light, there are 6 chances, second light 5 chances. So
One
it
second,
goes
one
on.
second, one second, Advait, 1 second. Okay, whoever was answering. You said if I want, first case was?
Out of the 6 lights, first we can place 1 light, 6 lights. So 6 options will be there to place the first light.
1 second, your line, your sentence framing is there's a problem. I think what you mean is out of the 6 lights, if I want to switch on only one light, there are 6 ways.
Yes, ma'am.
Agree? Okay, I'm completely agree. So even if I switch on one light in the room, there will be light. It's not going to be dark, right? It will be a little light, but it's still not dark. So out of the 6 lights, if I want to switch on only one light, in how many ways can I do that? 6 possibilities. Either I will on the first one, or I can on the second one, or the third one, right? So one light can be switched on in 6 ways. Right. What was the answer for the second line? 5.
Hey, ma'am.
Okay. What was the question? 5 is the answer for what? 2 lights to be on.
Yes.
How? I don't want the second line. I'm saying that in the room there are 2 lights which are on. Which two? It may be 1, 2. It may be 1 and 3. It may be 1 and 4. It may be 1 and 5. It may be 1 and 6. I've already given you more than that. नहीं नहीं जला. That was independent case. Case 1, as you proved now, case 1, the number ends with 0. So that has happened. Now when you're starting case 2, it has no connection with the first case. Mukit, same problem, I guess. Case 1, there is only one light. Case 1, one light on. How many ways? 6 ways. Yes?
Yes, ma'am.
Case 2,
No,
2 lights are on. How many ways? You are saying 5.
5 ways.
Explain. How? If I want 2 lights in my room to be on, I can switch on the first and the second light. I can switch on the first and the third light. I can switch on the first and the fourth light. I can switch on first and fifth, first and sixth. Again, second and third, second and fourth, second and fifth, second and sixth, third and fourth, third and fifth. There are so many ways. How will you calculate? It's not possible to do this. The human is huge. Again, if I go for 3 lights, how will you calculate? So with the second light, you calculated also. How will you calculate for the third one? How will you calculate for the fifth one? How will you calculate for the fifth one? 5 lights on, 4 lights on, 3 lights on. The idea behind it is not wrong. That I want a light in my room, so there should be something switched on. It can be one light, it can be 2 lights, it can be all the lights. There are 6 cases. It's a long process. रूम में 5 है. You are saying for one case. 2 lights are on, you are telling me 6 into 5. First, one light has to be on. There are 6 ways. हो गया. Now case 2. It may happen that there are 2 lights. See, if you are doing them together, that means you are switching on 2 lights. When you are writing cases, case 1, the number ends with 0. The case has to end there. It's over. When you write case 2, it's a clean slate. It starts again. So there are 6 different cases for us to figure out how many ways I can switch on only one light. In how many ways I can switch on 2 different lights. In how many ways can I switch on 3 different lights. So rather than thinking so many things, why don't we consider the same thing here? From the total, you will remove what you are not expecting. So first of all, for this, I want to know how many different possibilities are there for the 6 lights. See, if I say I want light in room, it can be done by 6 ways. For 1 light, 2 light, 3 light, 4 light, 5 light, 6 light, 6 cases. And then the number of ways has to be obtained for each one of them. So much of a work. Rather than that, can I not say total possibilities minus darkness. Can I do that? If I remove, and there is no light in the room, if I remove those cases, what will be left? A room will have minimum of one light. It can have more than that also. I have a problem with only darkness. The room should not be dark. There should not be darkness in the room, right? So how many ways are there for? First, let us find out total. Every light has one switch. Every switch has how many options? Every switch of a light. You have a switch in your room, na? Right.
Ma'am.
Your switch has how many possibilities? A light has a switch. You must have a switchboard. Everyone may have a switchboard in your room, right? So that switch, place your finger on the switch and you tell me how many ways are there for you. What can you do with that switch?
Two.
Two.
On
What
off.
is the two ways?
On off.
Yes, thank you. Basic common sense gawa rahe sabka sab. Either I can switch on the light or I can switch off the light. I'm talking about total. For total possibilities, every light has a switch. Every switch has two options. Either it will be on or it will be off. So first light has two options. Second light, two options. Third light, two options. All the six lights has two options each. So what are the total ways for all the six lights to be thought together?
Ma'am.
Sorry?
Ma'am,
didn't
I'm
get-
thinking the answer. Thinking for the answer.
Okay. See, again, let's think again. First of all, let us think no cases. Okay. Complete. Anything is allowed. Everything and anything is allowed. So I have six lights. Every light has a switch. Every switch has two options on, off. So what are the total possibilities I can have? All of one on, two on, three on, four on. All the cases are there. First light. Either I can switch it on or I can switch it off. Two options. Second light, again two options. Third light, again two options. So if you consider all the lights together, how many total options are there? 2 to the power 6, 2 into 2 into 2, 6 times.
Yes, ma'am.
Agreed. So it is
64.
2 to the power 6, 64. In these 64 cases, everything is included. Having maximum light, having minimum light, having no light, everything is there. Now what I wanted is my room to be illuminated. My room to have light. I did not say how much light, I just said light. So it can be done by one light, two light, three light, any light. What I don't want is for darkness. When will my room be dark? When all the
When no
switches
light.
are off. There is how many ways for that? Everyone has a room.
Yes,
Look at your
ma'am.
switchboards. In how many ways can you use the switches to have zero light in the room? Zero light, no light at all.
One time, ma'am.
Only one time. Switch off everyone. If I want darkness in my room, every single light has to be switched off. So first light, first switch has how many options? One, be off. Second light has how many options? One, be off. Third light has how many options? One, off. So all the lights has only one option each. So a total 1 to the power 6. There is only one way in which the room will be completely pitch black dark. Agreed? So I don't want that case. So from the total, remove that one case. Answer would be
63.
63.
63 ways.
In these 63 cases, there will be at least some ray of light. Sometimes more, sometimes less. But there will be some shred of light. Is it understood? So from
Yes,
the
ma'am.
total, I have removed what I'm not clear of, what I don't want. Is it okay?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Clear?
Yes, ma'am.
Yes,
Any
ma'am.
doubts? Let's try. Number one, there are 10 students who compete for a swimming race. In how many ways can they occupy the first three positions, given that no student can take the same position, even if they would not have written this line of this? So when I'm giving the first position, how many ways are there? How many people are there? 10. When I'm giving the second award, 9 options.
9,
Third award,
8,
total
720.
720. Because I need to give all the 3 awards, it's multiplication. Everybody clear?
Yes, ma'am.
Yes, ma'am.
Question number 2. Given 4 flags of different colors, how many different signals can be done if a signal requires the use of 2 flags, one below the other? Answer. So the first position can be filled by any one of the 4 flags. The second position can be filled by any one of the 3 flags. So a total of 12, because in the signal 2 are to be used. Is it okay?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Question, I would have added the word this. Given 4 flags of different colors, how many different signals can be generated if the signal requires the use of at least 2 flags? In that case, what you will do? There will be 3 cases. Case 1, 2 flags are used. Case 2, 3 flags are used. Case 3, 4 flags are used. I cannot use more than that. So 2 flags, 4 into 3, 12. 3 flags,
4 into 3 into 2.
4 into 3 into 2, 24. 4 flags,
4 into 3 into 2 into 1.
24. So a total of
Into
plus, because it will be or I can either use 2
60.
flags, or I can use 3, or I can use 4. So I'll add them. Total 60 possibilities. Clear?
Yes, ma'am.
Yes, ma'am.
Everybody?
Yes, ma'am.
Question number 3. How many 4-digit numbers can be formed from the digits 1, 3, 5, 7, 9? So I want to form a 4-digit number. So the first place can be filled in.
5 ways,
Second,
4,
4 ways,
third,
3 ways,
and the last will be
2 ways.
2 ways.
multiply, because all the 4 places has to be filled up to get the number 120.
120 ways.
4. Huh? See. Find the number of 4-letter words with or without meaning which can be formed out of the letters of the word rose. So I have 4 letters. In the first case, repetition is not allowed. I can use one letter only once. So the first place can be filled in.
4 ways,
4
Second,
ways.
3 ways,
3 ways.
third,
Okay.
2
2,
ways, 1
1.
way,
Total of 24.
24 ways.
And repetition is allowed. That means I can use one letter any number of times. In that case,
4, 4, 4.
4 power 4. 256. Yes.
Ma'am.
yes, ma'am.
Question number 5. In how many ways can you post 5 letters in 3 mailboxes?
5 cube.
Wrong. So the sum starts with what? I'll talk about the point of view. So I have in my hand letter. First letter, how many options?
3 ways,
Second letter, how many options?
3 ways.
3 ways,
Third letter,
3
fourth
ways,
letter, 3,
3 ways.
fifth letter, 3. So 3
3
comes 5 times, na? It will be 3 raised to the power 5, 243.
243.
Understood?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Everybody clear?
Yes, ma'am.
Question number
Yes.
6. In how many ways can you distribute 20 chocolates among 10 person, given that one person can take any number of chocolates? So if I'm distributing the first chocolate, how many people are there to as a taker? How many people are there to take that?
10.
There are 10
10.
people who can take that. So one of the person takes that chocolate, but the question says he doesn't go away. He's still sitting there to take the second one. If he would have taken the second one, he'll still be there to take the third one. He can take all also. So first chocolate, there are 10 people. Second chocolate,
10 people.
10
10.
people.
Third chocolate, 10. So all the 20 chocolates, each will have 10 options. So a
Yes,
total of
ma'am.
answer would be
10.
10 raised power 20. All the
Yes,
chocolates
ma'am.
have to be distributed, so multiply. Clear?
Yes.
Yes, ma'am.
7.
Yes,
In
ma'am.
how many ways 5 rings of different types can be worn in 4 fingers? If it is not mentioned, it's the modern era. So one finger can have many rings to be worn. I can wear a ring here, adjustable one. I can wear a ring here. Those category. If it would have been mentioned that one finger only one ring, then here in this particular question, 0 ways. Because for 5 rings, I need a minimum of 5 fingers if one finger is only having a ring. So this is the modern era. In one finger, you can wear any number of rings. So again here, you take the ring to the hand or hand to the ring. Obviously, ring to the
Right,
hand.
ma'am.
So I pick up the first ring. How many options? I pick up the first ring. How many options?
5.
5.
Five. I pick up the second ring. How many options?
4.
4.
No. 5. Modern
5.
era. I can wear the same ring in the same figure again. Any another position. Yes.
Yes, ma'am.
Third finger.
5.
Fourth.
5.
Fifth
5.
also 5. So 5 raised to the power 4.
5.
Ring तो 5 है तो मेरा ही wrong है. First ring, there are 4 fingers, no? So 4 options. Second ring, I can wear it in any one of the 4 fingers. So second, 4 option. Third ring, again, 4 option. 4 option, 4. So 4 power 5, na? None of you corrected me. So 1024. Yes? Guys, clear?
Yes,
Yes,
ma'am.
ma'am.
8. How many 5-digit telephone numbers can be constructed using the digits 0 to 9? If each, so there are 10 digits in a total, and I'm forming a 5-digit number. The number starts with 67. It is fixed. So the first place will be filled by 6. There is only one way. The second place will be filled by 7. There is only one way. And number digit appears more than once. That means repetition is allowed. So the third place can be filled by
10 digits.
10 places, 10 digits. Anyone can sit here 0 to 9. Fourth place can be filled in
10 ways.
10 ways because repetition
Ways.
is allowed. Again, the third one. So if I multiply, answer will be 1000.
1000.
1000.
Clear?
Yes, ma'am.
9. We just did the sum. There are 10 lamps in a hall. Each one of them can be switched on independently. So 10 switches. Find the number of ways in which the hall can be illuminated. That means I want light, but I don't want darkness. How many ways are there?
2 to the power 10.
2 to the power.
But 2 power 10 is total. You can't have darkness. So in how many
Minus
ways
1.
are doing it?
Minus 1.
Minus 1.
So 1 0.
1020.
2000.
Clear?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Question number 10. There are 5 MCQ questions with 4 options each. Even if they would not have written, MCQ means 4 options. Number 8. In how many ways can I answer them? Matlab, all the 5 questions have to be answered. So when I'm answering, if I get a 5 marks, 5 question MCQ paper, if I'm answering the first question, how many options do I have?
4.
4.
Second question, how many options?
3.
4.
Oh,
4.
Second question, how
4.
many
4.
options?
4.
4. Third
4.
question, 4. Fourth question, 4. Fifth question, 4. 4
4.
power 5.
1024.
Number B, in how many ways can they answer so that all are correct? So if I'm marking the first question and I want to mark the correct option, how many correct options are there?
1.
Second
1.
question also you need to mark correct.
1.
Third
1.
also, fourth also, fifth also. 1 power 5.
Yes, 1.
Third, all are incorrect. So first question, I want to mark an incorrect answer. Incorrect. Out of 4, there is 1 correct. So the 3 will be incorrect.
3.
Second question also want to mark incorrect one.
3, ma'am.
Again 3. Third
3.
incorrect. Fourth incorrect. Fifth incorrect. 3 power 5, 240.
243.
In D, it's written not all are correct. That means you don't need to mark all the 5 questions correctly. That means I need to mark all of them wrong. That's wrong. It says all of them should not be correct. That means all the 5 should not be correct. But 4 of them can be correct. 3 of them can be correct. 2 of them can be correct. 1 of them can be correct. None of them can be correct. So there are so many cases. So when we have so many cases, what do we do? From the total, we will remove what is not required. So not all are correct. Will be total minus what I don't want. What I don't want.
All correct. 1.
All correct.
All correct. So total, how many options are there?
4.
1024.
Oh,
And
1024.
all correct, how many options are there?
1. 1.
So
1.
1, 4, 2, 3.
Oh, 1023.
Clear?
Yes, ma'am.
Yes, ma'am.
All of you clear?
Yes,
Yes.
ma'am.
Yes, ma'am.
Any doubts?
No, ma'am.
Ma'am.
Okay, exercise 7.2, Amal Agarwal, question number 1. Let's start. Question number 1. There are 22 boys and 17 girls. The teacher wants to select either a girl or a boy. Either or. Either or is plus. So, how many ways are there to select a girl? 22 girls, 22
22.
ways. And how
17.
many ways are there to select a boy?
17.
And since it is or, we add 39 ways.
39.
How will I present? Number of ways to select a girl, 22. Number of ways to select a boy, 17. Total number of ways, 12, 22 plus 17, 39. Clear? Question number 2. There are 11 cricket players. One is to be chosen as a captain and another as a vice captain. How many choices are there? So, how many choices are there to select a captain? 11 choices.
11.
How many for a vice captain?
10.
Because if one is
10.
selected for the captain, he can't be the vice captain also. And I want both of them and so multiply. 110. 3. There are 4 doors in Lotus Temple. In how many ways can a person enter the temple but leave by a different door? When I'm entering the temple, there are 4 gates, first, second, third, fourth. So there are 4 ways to enter the temple. But if I've entered by gate 1, I cannot exit by gate 1. So to exit, I have only 3 ways, remaining 3 doors. And I have to enter as well as exit. So a total of 4 into 3, 12 ways. Is it okay?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
So the chairs in an auditorium are to be labeled with a letter and a positive integer not exceeding 10. First, a letter has to be selected and then a number has to be selected, 10 or lesser than 10. So the first position has to be filled by a letter. How many ways are through to do that? The first letter can be chosen in
26 ways.
26
26
ways.
ways, 10
And the
ways.
second, the number can be chosen in
10 ways.
10 ways because 0 is not included, right? because it said positive integer. That's why 0 can't be included. So from 1 to 10, there are 10 possibilities. And to name a chair, A1, A2, A3, I need both of them. So multiply. Fifth, कोई दिक्कत है? A tennis club consists of 8 boys and 11 girls. In how many ways can a mixed doubles team be chosen? A mixed doubles team. I only need to choose one team. I don't need to form a competing team. That means in that case, I would have had to choose one boy, one girl, one boy, one girl, right? Right now, I only want to form one team, one mixed team. So I have to select one boy and one girl. Both of them has to be selected. So one girl can be selected in 11 ways. One boy can be selected in 8 ways.
8 ways.
Both of them needs to be selected 88 ways.
8 ways.
There are 21 towns in a district connected by railways. Find the number of tickets required by the railway so that a passenger can travel from one town to another. So just imagine like it's an online portal, right? You're correct. So in order to form a ticket, we enter two things from where to where. Starting journey location, ending location. So as it said, there are 21 locations there. So when I'm entering the location for the starting point, from how many options will pop up? 21. I can start my journey from any one of the position. So there are 21 ways to choose for the starting location. If I've started from point A, I will definitely not land up at point A. I'll go to a different position. So when I'm choosing my two location, where I'm gonna end up to, right? So that location will be any one of the remaining 20 cities. Yes. So how many total options will be there? 21 into 24, 20 options. Yes or no, guys?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
7. A coin is tossed 4 times and the outcomes are recorded. How many possible outcomes are there? So first coin, 2 options, second coin, 2 options, third coin, 2 options, fourth coin, 2 options. All the 4 are tossed. So 2 to the power
2 power 4, 16.
8. In a class test, a teacher decides to give 5 questions, one each from the first 5 exercises. The first exercise has 7 questions, and I want to answer only one of them. So, for the one question can be answered from the first exercise in how many ways? 7 ways. I can choose any one of the 7 questions. In the second exercise, there are 12, and I want to select only one question. So, one question can be selected in any one of the 12 ways. Third exercise, 6 ways. Fourth exercise, 10. Fifth, 3. One each. That means I have to answer one from everyone. One question from the first, and one question from the second, and from the third. So what will I do? Multiply
Multiply.
them. Answer
15120.
15120.
Yes, ma'am.
Yes. 9, number 1. Find the number of 4-letter words with or without meaning which can be formed out of the letters of the word honest. The repetition is not allowed. So honest has 6 different letters. I want to form a 4-letter word. First letter can be chosen in 6 ways, then 5 ways,
5
4
ways,
ways,
4
3
ways,
ways.
3 ways, 360 ways.
Very good. Clear, everybody?
Yes, ma'am.
Yes, ma'am.
Second. For a group photograph, 3 boys and 2 girls stand in a line. So total 5 people are standing in the line for the photograph. In how many ways can we do that? So if 5 people are standing, so there are 5 positions to be filled up. So the first position can be filled up in
5
3
ways,
ways.
5
second,
ways,
4 ways,
4
third,
ways,
3
3
ways.
ways,
3 ways,
then
2 ways,
2
and
ways,
1
1.
way,
120 ways.
120
total
ways.
120 ways. Hmm? 10. How many 4-letter code words are possible using the first 10 letters of the English alphabet? First, no letter can be repeated. So I want to form a 4-letter word. I have 10 letters total in option. First letter can be chosen in
10 ways,
10
second,
ways,
9
9
9
ways.
ways,
ways,
8
8,
and 7.
7.
Total
5040 is 5040.
5040.
Second, in the same case, if repetition is allowed, each option will have 10 possibilities, 10 letters. So
10 power
10 into
4,
10 into 10 into 10, 10 power
10,000.
4 or 10,000. Yes.
Yes, ma'am.
11. How many words with or without meaning of 3 English alphabets can be formed? Now, in this question, again in the second line, they asked us how many of them will have all distinct. That means if they've asked me that separately, in the first one, they don't want distinct. See, in a normal scenario, if they would have told me form a 3-letter word, I'll always take them distinct, no repetition, right? But since in the question, they've asked me 2 questions and in one, they've specifically told me to take distinct. That means in the other question, repetition is allowed. So if repetition is allowed, then how many possibilities are there? 26
Twen-
option, 26 option, 26 option. 26 cube, 2652. No. Answer
175.
17576. Second, if they are all distinct, no repetition allowed.
26 into
26
25
into 25 into 24,
before.
15,600. Clear?
Yes,
Yes,
ma'am.
ma'am.
12. Only one question is there. Okay, it's my fault. 11 2. Two cards are drawn one at a time without replacement from a deck of 52 cards. Determine the number of ways in which the cards can be drawn. What will be the number of ways? Okay, first, 2 cards need to be drawn. So, first card can be selected in
52 is
52 and that is kept. It's not put back. So, now the second card will have how many options?
51.
51 options.
51 ways.
So, answer 2652. Now, in the second part of this question, what is the number of ways if the first card is replaced before the second is drawn? This is with replacement. So when I'm choosing the first card, there are again 52 options. I saw the card and I put it back into the deck. Then I'm picking up another card. So again, the deck has how many options? 52 options. Second can also be chosen in 52 ways. Total
2704.
704. 12. A number lock on a suitcase has 3 wheels. So usually, if I would not have read the other parts of the question, if I talk about a suitcase, the first place can be filled by 0. I don't want a 3-digit number, right? We all have lock combination 0, 1, 2, 0, 0, 0. Second, all the letters can also be same. In the lock combinations, we do keep 4, 4, 4, 2, 2, 2 to remember, right? But in this question, it said that you have digits, 10 digits, 0 to 9. But the opening of the lock is a particular sequence of 3 digits with no repeats. They specifically said that the repetition is not allowed. So the first place can be filled in 10 ways because 0 is allowed.
10 ways.
The second place can be filled in
9 ways.
9. Third can be filled in 8.
8 ways.
So a total of
720
720.
ways.
Any problem?
No, ma'am.
Any problem?
No, ma'am.
Okay, then. That's it for today's session. We'll continue in our next class.
Thank you, ma'am.